Hello, everyone, and good morning. Welcome to the second day of DevOps UK, and welcome to my talk. Your API is already a hidden MCP server. You just need to discover it. Let me start with a quick question for all of you. Does anyone here have an HDMI adapter? Okay, a few hands here. The second question is, why do we need it? Who can answer me that? Anyone? Okay. But simply because the newer USB-C laptops maybe don't have an HDMI input, HDMI port. What I want to say is that protocols evolve, and systems don't necessarily upgrade in sync. We are Infobip. We're a global cloud communication platform, and we help our customers reach their customers wherever they are, over any channel available. SMS, RCS, WhatsApp, Viber, or any geography, any regulation. I'm Filip. I'm a principal engineer at Infobip. Currently, I'm leading the MCP value stream at Infobip. Throughout my career here, I worked on our high-traffic distributed system. I was a part of the API governance initiative, worked on API gateway services. I developed a few of our public APIs. I also worked on SDK and docs auto-generation. I'm a mathematician, and I'm a lecturer at University of Zagreb as well. Like, privately, I'm a proud father. I enjoy music and sports. Okay, let's think about REST a bit. So REST API helped us build the world that we know today, the connected world that we know today. So if you think of mobile apps, any smart devices, interactive UI, CLIs, all of them are communicating using HTTP. That means decades of standards, tooling, and shared knowledge that we all built to really connect everything that we use today. And the HTTP API in general is the programmable connectivity layer between platforms today. And then AI agents arrived. AI agents are very sophisticated software systems, I would say, to which you give a goal, some tools to achieve this goal, and clear instructions. In short, AI agents needed to act. But wait, so how does an agent connect to decades of existing infrastructure? It was November 2024. I hope that the most of you here remember this. Anthropic announced Model Context Protocol, or MCP in short, as the first open standard for connecting AI applications to external data, tools, data sources, and systems in general. And they called it, okay, this is a USB-C port for AI applications. Early 2025, we at Infobip formed a small team. We applied for an internal hackathon because we wanted to give AI agents access to Infobip's platform, access to our channels. And I still remember the use case that we were trying to implement. So imagine that we own a small chocolate factory and that we wanted to draft and send a marketing campaign using WhatsApp or Viber, advertising our cool product. And this is something that we started with. And a few days later, we had something meaningful. We had our first MCP servers live in production. We wanted to build our MCP servers as satellite connectors that were deployed on top of the existing platform. So no rewrites. Everything is powered by the existing API stack. And we followed one core architectural principle here. We saw MCP as another abstraction layer, as another way to connect with our existing platform capabilities, with our existing platform services. But how? The answer was obvious. We had the OpenAPI specification. So every Infobip API is documented using the OpenAPI specification. And if you're familiar with the standard, so it describes the operation, it defines the schema, and most importantly, it was already there. A few years ago, I was here at Devox, and I was talking about how we actually built and published our public SDK stack by using the OpenAPI specification. And it was natural for us to continue in that manner, because like the OpenAPI specification is a core artifact of our API platform. Okay, but wait a minute. Isn't this wrong? I'm sure that you've all heard this. So never build MCP servers on top of the API. Why? Because obviously API and MCP are fundamentally different things. And simply because they've been designed for different audiences. HTTP API or REST API is designed for developers in a way. And the other one, the MCP, is designed for agents. So if you want to connect with the REST API, you need to explicitly implement the business logic in the code base. And on the other hand, if you want to integrate with MCP, you count of an AI agent to orchestrate that business logic for you. And this is a fundamental difference. And I fully agree. All of those are valid arguments. So REST APIs might be too granular. Agents need task-level tools. Also, if we expose our entire API surface, this may lead to potential security issues. And last but not least, let's talk about responses. So REST responses are designed for apps. They're designed to be parsed deterministically and interpreted that way, not for LLM context window and LLM context reasoning. But let's take a look at this. What is an MCP tool? It consists of a name, a title, a description, input schema, annotations, and a couple of other things, but let's focus on those. On the other hand, if you're familiar with the OpenAPI operation definition, it's clear how we can connect them. The name can be an operation ID, because operation ID uniquely identifies an operation within the specification. For the title, we can naturally use the summary. Description is obvious. We have a way to define the input schema by combining parameters in the request body, for example. And annotations, we can derive it from the HTTP semantics that we've been familiar with for decades. And just a little disclaimer here. This talk is going to be focused on MCP tool calls. And that's the primitive that we can directly connect to the HTTP API invocation. But also, other MCP primitives, like resources and prompts, can be expressed via the OpenAPI extensions, but they are out of the scope of this particular talk. And this bridge that we decided to cross, it was not a hack. It was an architecture choice that we made. Because when you are developing an MCP server, you want to express the right agentic experience. And if your API is designed for the right agentic experience, it can map to MCP naturally because of the correspondence we explained earlier. Okay, but a few important things. Not every endpoint should be exposed as a tool, because irrelevant operations add noise, they add additional costs, and they may even mislead the model. And also, every exposed operation, as I said, may potentially extend prompt injection attack surface. Also, as you've already had a chance to see in practice, LLMs often struggle with large contexts, large surfaces. That's why we need focused tools, focused specifications that produce more reliable decision making. Okay, and we said that MCP is a USB-C port for AI agent. That means we need an adapter. We need an adapter that will bridge the REST API world to the MCP world, to the agentic era. And here is the adapter. So we developed an open-sourced Infobip OpenAPI MCP Spring Boot starter, and it's available for everyone. Feel free to explore it. Feel free to use it. And it's simple. You just point it at an OpenAPI specification, and your API instantly becomes an MCP server. And this is something that we've been running in production for months now. Like, it works, it's scalable, and it really enabled us to be there, to like publish our own MCP servers and to make our platform available to agents. What's important to mention that it's built on existing foundation. So it's based on Spring AI, which is again based on the MCP Java SDK. So it's a Spring Boot starter, and you get everything from it that you would expect. And this is all you need to write to start. You include the dependency, you configure it. Take a look at this on the left-hand side. So you just need to provide the OpenAPI URL and your downstream API-based URL. Configure the Spring AI to expose an MCP server using the transport layer, the protocol you like the most. And of course, like with any Spring Boot starter, you can easily customize it by providing your own bin implementations and additional configuration. Okay, but how does it work? We have a setup phase where we read and transform the OpenAPI specification. We built MCP tool metadata out of it. We register tools with the MCP server. And this happens at startup and also on live reloads. That means if your API is changing, we can pick it up like immediately. There is also a runtime part of it, even more important, which happens on every tool call. Here, we validate credentials, we map tool arguments to HTTP request, we enrich and forward the HTTP request to the downstream API platform. Then we'll, of course, handle some errors and return the result back to an agent. Okay, let's talk about setup a bit. We have the abstraction that we call OpenAPI Reader, and is built on top of Swagger parser. We read the OpenAPI specification and store it in the memory. Then it's possible to apply the OpenAPI filter chain. And this is very important in the context of like targeting the right agentic experience, because it enables us to modify the OpenAPI specification on the fly. Then we have a resolver part where we need to resolve all the ref schemas into a flat model. This is something that I'll talk a bit more about a bit later. We store the model in the OpenAPI registry, and it becomes available to something that we call tool registry. This is the part of the framework that maps HTTP operations to MCP tools, define handlers to be called, etc. And then we have the OpenAPI MCP configuration, which is simply a bridge between our framework and Spring AI. So, the OpenAPI specification. If you haven't seen a standard before, so this is roughly how it looks like. You're able to define the pods. For example, we have SMS3 messages pod here. We can define the operation. In this case, we have post operation. Then we can describe it. We have summary, we have description, this SMS matching tool enables you to send messages, etc. We have the operation ID, and then we can define the schema. So here is the request body, here we have a reference to component schema's SMS request, and we have some examples. In this case, how to send a basic textual message. Once again, I would like to emphasize another core architecture principle that we have here. So every HTTP operation in the specification becomes exactly one MCP tool. So we keep this one-on-one correspondence between the API and the MCP tools. Filtering the spec. Why is this important? There are situations when you don't even own the underlying API, when you cannot modify the OpenAPI specification, and you need to make some changes again to get the right agentic experience. As I said before, so sometimes you don't want to expose your whole API surface to agents, and that's why we need filters. So it can be literally everything, from filtering out the tools, changing and modifying the input schema, like removing some kind of JSON schema, property validation, hence. It can be everything. You just need to implement the OpenAPI filter, and you can register like any bin implementing this interface. It will run in order before tool extraction. And I'll give you one example here, which is probably not the simplest one, but a very powerful one. So we all do object-oriented programming, and we are kind of familiar with the polymorphism in general, and polymorphic way of expressing our models. The OpenAPI has a concept called a discriminator, which enables us to define the discriminator property, in this case a channel, and then based on the value of this property, we can define the different schema. And it's something that is very cool actually, because it enables servers to validate the input more easily. So based on this property, we can validate the schema against we can validate the request against the particular schema that is defined. But it's not necessarily very important when we want to match the exact input schema. For example, what we can do, we can easily convert the discriminator part into the structure that is called one-of. We will just provide, okay, your input schema may be one of the SMS schema, RCS schema, WhatsApp schema, etc. And why is this important? Discriminator is a part of the OpenAPI definition, and it's not a part of a valid JSON schema. And MCP tool definition explicitly specifies the schema version that the input need to adhere to. Okay, and this is just an example. This is how we actually handle this particular issue, but as I said, anything can be done with OpenAPI filters. Let's move forward. APIs accept the path parameters, query parameters in the request bodies, and MCP tools expect a single JSON object. And the framework is here to help us. So it's very natural actually, because if our API accept only path parameters, query parameters, header parameters, we can easily put them into the flat object, one property per parameter. However, it gets more complicated if we have both parameters and request body, and then we need to do some kind of wrapping where we actually combine the body and the parameters in a single JSON schema. And this might be very natural, but of course it requires additional processing, and the framework handles that for us. The important part are references, as you had a chance to see on the previous slide. We cannot expect LLMs to kind of look through some kind of reference storage and be able to deduct the schema on the fly. It may result in more token consumption, and it can be very unreliable. So that's why we resolve it like beforehand, and we make sure that every tool receives a complete self-contained input schema. Okay, but how does an agent select our tools? We have names and descriptions, and names really drive the tool selections. So LLMs pick tools by name as description and as set, And here we offer 3 strategies for tool naming. We can use Operation ID directly from the OpenAPI specification. There's also an option to sanitize Operation ID, so to convert it to lowercase and replace all the special characters with underscores. And if your OpenAPI specification simply does not provide Operation IDs, you can choose the endpoint strategy that will basically combine the HTTP method and the bot. And also, like, it was not simple, because MCP is a relatively new specification. And like in the previous months, we saw everything, like in terms of MCP client adopting the specification. So we offer something that we call trim naming strategy that can actually trim the length of a tool name, because some MCP clients rejected like even registering tools if their names were too big. So you can trim the length of it right now. Okay, descriptions. Every tool description from every connected MCP server is loaded into the LLM context. That means it needs to be reasonably short, it needs to be clear, it needs to be concise and informative. And last but not least, it needs to be written in the edge agent-friendly way. So naturally, we'll use the OpenAPI description for a tool description, but we can combine it with a summary, and also we can add examples, which is very, very powerful when it comes, especially when it comes to input schema matching. And again, we offer a few strategies here. You can skip all the examples, you can include all of the examples, and you can use only annotated examples, which is probably the most powerful strategy. And here we again use the OpenAPI extensions concept to annotate a particular example to be included as a part of the MCP description. Okay, we are done with the setup phase. We have our tools registered, we have our tools ready. And now let's take a look at the runtime phase. What actually happens on every tool call? Like, the most important thing to mention here is that the framework acts as an MCP gateway to your platform. And that's very powerful. The framework will provide authentication mechanisms in a way. It will decompose the request, because we need to bridge that gap. We need to like go from the composed JSON back to the HTTP headers, HTTP like query parameters, path parameters, and request body. Also, the request to the downstream API can be enriched. We can add additional observability headers, we can like change the user agent if needed, we can provide any other custom metadata. And also, if you work with Spring in general, you're familiar with the concepts of filtering. So we provide tool call filter interface, and we run the tool call filter chain, which enables us to modify request or response if needed, or even to prevent the call entirely. And the most important part is, of course, calling the downstream API, executing the HTTP request, and getting the response, interpreting errors if needed, and also returning the result to the MCP client. And once again, the important concept, the framework acts as an MCP gateway. Authentication, one of the probably like most debatable parts of the MCP specification in general. And what's the challenge here? So MCP must reject all unauthenticated requests. That means that credentials must be validated before any tool runs. Okay, but we are a gateway. We don't know how to perform authentication out of the box. That's why we need additional configuration. So we provide OAuth URL configuration property that you can use to provide any existing API endpoint that validates credentials. Because your API already knows how to perform authentication and authorization. So it knows how to reject bad credentials. And also there is a concept of credential provider. By default, we are going to read credentials from the authorization header. But we might want to read credentials from the environment, from Vault, from database. It doesn't need to be like the authorization header. And why it works? As you had a chance to see here, so we are not limited to one particular authentication mechanism, to one particular schema. We pass the credentials as they are to the downstream API. That means we can support API key, basic auth, JVT, auth. So whatever the downstream API accepts, the MCP is going to accept as well. That means no custom auth logic to write. Okay, OAuth. MCP specification evolved fast, and the core authentication mechanism is relying on the OAuth protocol. Scope discovery, dynamic client registration, even the auth server discovery, they were all part of the specification, even changed through some versions. But the problem was that all of those changes and the whole specification was interpreted differently across clients in the last few months. So we tried to encapsulate all of those interpretations, and we tried really to follow the specification as is evolved. So the idea is, again, to have one property, OAuth.url, then you can use to point the framework to your OAuth authorization server. And that's it. We'll proxy the OpenID configuration call to your authorization server. We'll proxy OAuth authorization server to your authorization server. And we can also construct the OAuth protected resource response on the fly. Okay, we focused on authentication here, but let's talk about the authorization as well. So MCP servers need to be secured. And most importantly, we kind of wanted to provide the least privilege concept by default. So we're going to perform scope discovery as well. So we can read all the scopes from the OpenAPI security definitions or even custom OpenAPI extensions. And we'll use all the mechanisms that the MCP specification provided us. So we can return the scopes back to the MCP client so they can be specified when creating and requesting the OAuth client. And that's it. So to have the full OAuth support, you need to point it at your OAuth server, and you'll get minimal scope discovery automatically directly from the framework. Okay, one additional story. So I said before that we struggle with MCP client adoption in general, and we faced another issue that was rather interesting, I would say. We noticed that some MCP clients serialized nested JSON objects and arrays as escaped strings. For example, we had a messages array, and this simply array of messages that should have been sent, and we noticed that instead of an array, we received an escaped string. And this was obviously bad. So we would get 400 from the downstream API. Okay, But what we can do here, how we can like fix this and make it transparent to the MCP client. Okay, we simply send the request as received. And if we get 400, we scan string value properties, and we look for embedded valid JSON. So if we find this kind of string, we deserialize it in place, we retry the call with the corrected body, and see what happens. And this is just one of the examples how challenging it is to work with emerging technologies. But this is why we try to encapsulate all of those fixes, all of those adjustments inside of the framework. Okay, let's see how it works in practice. So what are we going to do here? We're going to use the OpenAPI API to get the weather forecast. We're going to use this framework to build an MCP server on top of it. And we are also going to use the Infobip SMS MCP server, our production MCP server, to send SMS messages. So you can find the MCP server at mcp.infobip.com/sms. And then you'll see that we will have an agent, and we'll prompt it to like pull us the weather forecast for London and send it to us using the SMS. Okay. I hope that you can see the code here. So this is our GitHub repository here. So our Infobip OpenAPI MCP Spring Boot starter. There is an examples directory. And let's take a look at this OpenAPI MCP. Let's take a look at the POM XML first. And we'll see that we have only a single dependency. And this is the only dependency that we need. We have the Spring Boot Maven plugin just to provide a static jar name, which we can reference to later. And that's pretty much it. If you take a look at the code, it's super simple. And this is the only clause that we have. We just need to run our Spring application. In this case, we'll use standard I/O transport. That's why we disabled the web application in general. And that's it. We run the application. No additional code required. Let's take a look at the resources, our application YAML. And let's take a look at the configuration. As I said earlier, we need to provide the root URL to the OpenAPI servers. That's api.openmedia.com, and we need to point to the OpenAPI specification. Okay, let's see how this specification looks like. So, OpenAPI API, we have description here, and we have some pods. So we have a pod version 1/forecast. We have a get operation. We have a summary. Perfect. So this endpoint can give us a 7-day weather forecast for certain coordinates. We have a description. We have some parameters. We have an enumeration here. And that's pretty much it. Yeah, the response is defined here. Great. Okay, let's go back to the code. What else do we have here? So we opted in actually for the endpoint strategy because the specification hasn't provided operation IDs. So we needed to use the HTTP methods and pods to construct the tool name. And here is the Spring AI configuration part. So Spring AI MCP server will use the sync type, and we enabled standard input-output. Okay, let's take a look at another example just briefly here. just to show you how we can configure other transport types. We have another cool feature that is called mock MCP. Why is this important? So this feature enables us to mock downstream API responses, and you can imagine that this can be very useful in benchmark testing simply. If you want to evaluate the performance of your MCP server by using different LLMs, for example, you can use this mock mode to have the more reliable benchmarking. Okay, but the important part here is the configuration again. POM XML, identical. Source code, even simpler. Just one application class with code where we actually construct new Spring application builder on top of this class and run it. Regarding the configuration, base URL, again, in this case example.com because it's mock. OpenAPI specification describing Infobip's SMS API, here it is. It runs in mock mode. In this case, because it's a mock, the security is disabled, but for the real MCP server implementation, we can enable it and provide the OAuth URL. The Spring AI part, pretty much similar, but with an important difference. Now we use the stateless protocol. And that's it. And I would like to mention one thing. I said earlier that we use this framework for running our MCP servers in production. However, we modified our specification significantly to, again, achieve the right agentic experience. But what I wanted to say, this is the code that we run. It's been tested, we've been running it for months. Okay. Let's take a look at this video here. Okay, first, we are adding OpenAPI MCP server that you had a chance to see. After that, we are adding Infobip SMS MCP server. And let's see how it looks like here. Perfect. OpenAPI has been connected. We have a single tool, get version 1 forecast. And let's move forward. Let's see if we can connect to the Infobip SMS MCP server. And the MCP client, in this case, Cloud Code's MCP client, will automatically run the OAuth flow for us. So we've been redirected to out.infobip.com, a place where we can provide credentials. And this is the authorization part that I was talking about. So we performed scope discovery, and the client was able to ask for the correct scopes. And that's it. Okay, let's see what we have now. /MCP again. We have 2 MCP servers now, and those are the tools for Infobip SMS. Okay. What are we going to do here? We are going to fetch the London weather forecast for tomorrow. And we'll compose a brief summary and send it via SMS to this particular destination using the Infobip SMS MCP server. And let's see. Okay, calling OpenAPI as expected. Perfect. Now calling Infobip to send an SMS. And here it is. The SMS arrived. And we have our London forecast for tomorrow. It says that it's going to rain and we should bring an umbrella. But please double check this. So the demo was recorded 2 days ago. Okay. I already talked about some challenges that we faced. And I would like to emphasize this once again. It was like building on a moving train, literally, because the specification was changing. So the initial release introduced standard input-output HTTP plus SSC transport, no OAuth. Then the next version introduced streamable HTTP and deprecated SSC. And we started talking about OAuth for the first time. So sometimes we needed to pick between features and compatibility. We decided that we want to move fast. We wanted to be in that space. We wanted to provide connectors for AI agents. So we wanted to expose new MCP products. We wanted to expose new APIs, and we want to ship integrations. And the spec was still being written while we were shipping production code. And as I said, every new MCP client introduces a new set of compatibility surprises. So OAuth maturity level. Some clients fully compliant, others partially. As I said, tool name length limits, JSON serialization issues, scope discovery gaps. And we're building this framework to absorb every workaround. So users, at the end, we don't have to. My point here is that sometimes you can't wait for the ecosystem to mature. You ship and you adapt. And the real foundation is that none of this would work without the right team. We started with a hackathon. Then we formed a cross-functional team that consisted of engineers, product people, go-to-market people, because we really wanted to move forward. And now, a few months later, we're in a situation when we are running a bunch of MCP servers in production, and where we're building more and more products in the agent connectivity space. And I would like to emphasize 3 things. First, your OpenAPI specification is already a tool manifest. So every operation ID, every parameter, every description, the LLM can read it all. And your specification quality is your MCP server quality at the end. So that means if your API is designed for the right agentic experience, your MCP server will be as well. The patterns exist. Use them. So scope filtering, schema enrichment, or delegation, naming description. The framework wires them, but you control them. And the spec will move again, ship anyway. This is not applicable to MCP only. So the new technology is going to come. The new standards are going to emerge more and more. Sometimes we need to adapt, and we need to ship anyway. And we need to find the right group. So we need to build with people who are comfortable with this uncertainty. So your API may already be a hidden MCP server. Try to use this framework, point it at your specification, and ship it to agent. Thank you very much. Okay, do you have any questions, maybe? Yeah, thank you.
Very good presentation, thank you.
Thank you.
MCP server is new for me, so maybe my question is a bit silly.
Okay.
Sorry for if it is. Why MCP server, I imagine it's something which has to be used everywhere, obviously, because of AI and this integration, as you explained, to existing API or tooling. Why Infobip? You feel that you had to write your own library to integrate that into Spring, if I'm correct, as opposed to use, I'm sure there are solutions on the market. Why did you have to write your own wrapper, if I may, and as opposed to go for something on the market? Is it because the
Mhm.
market was, what was out there was not good enough?
Mm.
Or
Yeah, thank you very much. A great question. So the question was why we decided to build our own framework, because we could possibly use something that was there on the market. The thing is that there were some solutions on the market, even some open source solutions that we actually started using at the beginning, but none of them provided the feature set, the complete feature set that we needed. Also, there was nothing on the market that worked in this specific technology in Java-based framework like Spring AI. And we felt that it was a gap there. That's why we decided to build something and like give it to everyone. So that was the idea.
and if I may ask,
Mm.
would you know if Spring Boot Foundation
Mm-hmm.
will provide this kind of wrapper out of the box, part of the Spring Boot package looking forward? Or
Yeah, we'll see for the future. Right now, there is no something like this, so that's why we decided actually to build it. So, like the thing is that this architectural decision when building on top of the existing API is something that does not guarantee you to have the best possible performance because of all of the reasons that I stated before. So REST API are really not built for agents. So you need to make sure that your API is designed the right way to like achieve what you want to achieve actually. That's why this is an adapter. Yeah. Yeah, thank you. Thank you. Sorry.
Yeah, hi, it's a great presentation. So, as I understand, you're trying to bring multiple APIs behind an MCP. That is the.
Mhm.
So, what are your functional use cases? Like, I'm still trying to understand. What are your functional use cases? How are you using it today?
Thank you very much for a great question. The question was how do we package our APIs in the MCP server? What are our use cases today? So we as a platform, like we expose channels and we have like a lot of other features like marketing automations, like fraud detection, a lot of other like features that are built around the communication. So we try to package our MCP servers per product or per use case. You had a chance to see the SMS MCP server. So this particular MCP server will provide you everything that you need to send SMS message to our platform. Then we have an SMS server for sending WhatsApp, SMS server for sending RCS. But we have MCP servers exposed like for other features, for customer data platform, like we also like building MCP servers around channel provisioning, like everything that we feel that is scoped in a way that can be like independently and reliably used by an AI agent. And I hope that this answers your question. Okay, thank you very much for a great question. Please.
Great presentation. I do believe that the REST APIs aren't really native for agents.
Mm-hmm.
You started saying you repurpose your REST APIs to MCP servers so they can be compatible.
Mm-hmm.
And then halfway you also said that you had to change, or the APIs have to be adapted or specified for MCP. So what does that change you had to do to your existing APIs? Because they
Perfect,
MCP
yeah.
is in later, right?
Thank you very much for a great question. So the question was related to how do we map the existing APIs, like to match the basically the agent. Yeah, what changes did we need to introduce? Like one change is obvious. So we use the OpenAPI specification for multiple things. We use it for rendering our API documentation. We use it for like generating our SDKs. And if you take a look at the description, you would write a different description for API documentation, different description for Javadoc, and different description for the LLM context. So this is the first important change that we need to make. Also, like when it comes to input schemas, like LLMs like tend to have issues with very complex nested schemas. So we need to sometimes pull out some features that we found they are not that important for the agentic world, for example, to simplify the input schema. Also, we need to remove some tools because we didn't find them useful in this particular context. So those are like 3 main directions that we took. But I would say the descriptions are probably the most important because this is something that lands in the context. And this is something that like helps the LLM, the agent, to select your tool and reliably calls it. You're welcome.
So are you really maintaining 2 versions of specs
Not only 2, we actually maintain.
for each of them? So one is for actual API consumers and the other one is for MCP.
Yeah, we have the version of the MCP specification for the API documentation. We have the MCP per product. We have MCP for public SDKs, MCP for, not MCP, sorry, OpenAPI specification for documentation. We have per product OpenAPI specifications for building public SDKs, for MCP servers. So we have a way to like easily expose the OpenAPI specification on top of like a set of features that we want to be included in it. Yeah. Thank you for a great question. Yeah.
Is it accessible? Can we also see? Is that information public?
The OpenAPI specification.
The multiple that you said you were meant.
Some of them, yes. I think that we are out of time. Sorry for that. You can catch me later. I can show you. Okay. I can show you. Like our OpenAPI specifications are public. Yeah. Thank you very much. Yeah.